Okay, my friends, so we're going to have some fun in Excel right now. We're going to pretend we're statisticians studying a population. Now, that population is going to have absolutely no context whatsoever in this problem because the context you'll figure out in your careers. Whether you're a psychologist studying brain function or a med school student studying the effects of a rehabilitation method on a muscle injury, your context will come to you through wherever you end up studying. All we're going to do here is see what sampling from a population can tell us about that population. Now, speaking of population, on this first tab right here, when you first open the spreadsheet up, you'll see your population. It says, here's your population. And if you scroll down, you'll see what looks to be a big gray rectangle. Now, believe it or not, I've hidden numerical data inside that rectangle. And those of you that are Excel curious, you can kind of click in there and look around and see what the functions are. But I've left it grayed out because here's the deal. When you study a population, you don't get to see the entire thing. It's hidden from you. You actually get to see your sample. And that's what I've got down here in this tab. Let's sample. If you click over here, you're going to see very similar to the first tab, a large grayed out rectangle. But now there are going to be certain values that are highlighted and bolded. Now, there are 30 of them because I've decided to take a sample of size 30 from that population. Why 30? Don't worry about it. Ask your 244 instructor. I just needed to pick a number and 30 popped into my head. It doesn't matter anyway. What matters is those 30 data points are being selected randomly. And for those of you that are saying that's not enough data, you're about to see why it actually is enough data. All right, first thing I want you to do is I want you to find the average of the sample values that are here. Now, there is a function in Excel, we've talked about it, called the average function, average. If you type out the word average and then hit a left parentheses. Now, you've got to put the data values in parentheses that you want to average. Now, what you don't want to do is go try to click all of those. You want to select the entire gray rectangle in this case, and you'll see why for a couple reasons. First of all, it's only going to average the 30 that it sees. And press enter. So there's the average. Whoops. I don't know what just happened. My spreadsheet went completely bonkers. There we go. The average is 1,525. Ignore the margin of error for just a second. We'll come back to that. Now, what you may have also noticed when you do that, though, is your sample changed. We've got new values now. And that's because I've set up the spreadsheet to re-randomize every time you recalculate the values in the spreadsheet. Now, how do you do that? Well, in my computer at work, I just simply press the button that says F9. Here, I'm going to press it right now. There. And now I got a new sample of size 30. I can't see any data values up here, but if I scroll down, they're going to be down there. Okay, if I press F9 again, there's a new sample of size 30, and a new sample, and a new sample, and a new sample. For your computers, you're probably going to have to hold down another button while pressing F9. From my recollection, Macintoshes usually have to press either the button that's called FN for function or command. Windows users very often have to either hold down the function or control. See if you can figure it out. If you can't figure it out, just shoot me an email and I'll figure it out with you. Now, that average is only based on the sample of the 30 values that I've got down here. You may have noticed that after you typed the average, the margin of error also popped up. I don't want you to worry about the calculation of that margin. I also don't want you to worry about why it changes every single time. You notice the margin's staying pretty close to the same number, but it's moving around a little bit. The reason for both of those things will be explained to you in inferential stat if you take inferential stat. That's Math 244. Your job with that margin of error is to use it to estimate the average of the population based only on the average of that sample. And what we're going to do next is we're going to go into the next tab and do just that. So let's go on over here to sample, use that margin of error. Now, when you click over here, you're going to notice that the exact same average and margin that you have in the previous sheet are being called over to here because I'm fancy like that. And what you're going to do now is you're going to add and subtract that margin from that average over here in these cells. I call them LCL and UCL. In industry, you'll often hear lower confidence limit and upper confidence limit. Those are the left and right bounds of the confidence interval that your parametric average is likely between. So I'm going to click in this first cell here for the lower confidence limit. I'm going to type equals. Then I'm going to click on the cell for the average. hit minus, and then click on the cell for the margin of error. And in the upper confidence limit, this is going to sound somewhat familiar because we've talked about it in our previous discussions about margins of error. You're going to click on the average. You're going to add the margin and press enter. So there is now your new confidence interval. Granted, it definitely did reset because we got new data, and every time you re-randomize, it's going to give you new data. So those intervals are moving around a little bit, right? There it goes from about 965 to 1546. There's 1246 to 1883. You can just keep going, keep going, keep going, keep going. Once you get bored of generating random intervals, try the next couple questions.